Hey class, Absolute 5 here, and today we have to subtract mixed numbers. Last time we did addition, so the concept is the same as addition. So you're going to subtract the fraction parts first, and then you subtract the whole number parts first. So let's get right into it. Now, bear with me. This is going to be interesting to explain. Subtract 3/6 over 7. Okay, as I'm subtracting this, what's the LCD of 7 and 14? It's going to be 14. 6 times 2 is 12. 6 times 1 is 3. Alright, so now, let's understand something here. We cannot have a negative fraction in a mixed number. It just doesn't look good. It doesn't make any sense. It's kind of like it will kind of look like this. Like it looks something weird like this, and I wouldn't know what the heck that is. It will look weird. So the point is that I cannot subtract 3 minus 12 and I get negative 9/14 as my answer. So you cannot do that. That's out of the question. So I need to borrow 1 from this 6. Now, with this 1, understand, now hear me very carefully. With this 1, I'm going to put this, put this 1 over here, right? With this 1, I could pretend this 1, and probably this is actually the best example I can give. If you've played the game Pokemon, this number 1 is actually Ditto, the Pokemon Ditto, because it can turn into any number you want it to be. And let's be honest, it's actually, 1 is technically everywhere, technically, in mathematics. So, with this 1, right, I'm going to make this 1, I'm going to first observe, think of it this way, you're converting this 1, this whole number 1, into a fraction. And to do that, how do I get 1 as a fraction? All I have to do is take 2 of the same numbers, for example, the numerator and the denominator. If they're the same, I get 1. So if I decided to make this 14 over 14, why? Because that's what the LCD is right now. Isn't it true that 14 over 14 gives me 1? Right. So I'm going to add this 14 over 14 to this 3 over 14, and I'm going to get 17 over 14 minus, I am minusing the 12 over 14 already. I subtract this, I get 5 over 14, and that's just the fraction part. Now we're going to do the whole numbers, so 6 minus 3 is just going to be 3. We'll do another one. All right, so this one here, the LCD is going to be 21. So in this case, I don't have to borrow. I can just simply subtract, and I get 7 over 21. 8 minus 5 is 3. So again, real quick, I had to find out what the LCD of 721 was, which is 21. And then I multiplied the numbers to actually get what I needed. So 1 times 21 is 21. 1 times 2 is 2. 7 times 3 is 21. 3 times 3 is 9. I subtract the numbers and I'm left with 7 over 21. Now, can I reduce this? Yes. In situations like this, you should reduce this. So I get 1 over 3 as my answer. One last one and I'll be done. Okay, now, first off, you're looking at me like, Professor, there's nothing there. There's no fraction part here. You're looking at me like I'm crazy. And that's fine, because technically, not this problem, but the previous problem, I can still technically take out a 1 from this 14 to become 13. Now, with this 1, what's the denominator that's here? 7. So I want to make this number 7 over 7 because if I were to divide these two, I get 1, right? So I'm going to put 7 over 7 in the space that was empty, and now I'm going to subtract these like normal. I get 4 over 7, 13 minus 8 to be 5, 4 over 7 as my answer. So, for fun, this is your homework. 32, 7 over 9 minus 16, 5 over 18 as your and you work that out for yourself. Okay? So, that's the lesson for you guys. I hope you enjoyed it. Be sure to like, share, and subscribe to this channel. Press that bell button to receive more content. And I excuse me. And I hope to see you next time with another video. This has been Absolute 5. I'm Roger Palomino. Math is infinite because there are infinitely many possibilities. And don't forget, don't hate, calculate.